This video will cover section 8.6, further graphing of quadratic functions. Our goals in this section are to write quadratic functions in vertex form. We're going to derive the formula for finding the vertex of a parabola, and we're going to find minimum or maximum values of a quadratic function. First, let's talk about why we would want to change a quadratic function into its vertex form. Basically, if you're graphing by hand, it's a lot easier to graph a quadratic function when it's in its vertex form than when it's in its standard form. Let's start by looking at an example of a quadratic function in vertex form. We're going to write down everything we know about it and then sketch a graph. The first thing that we can notice from this quadratic function in vertex form is that the vertex is 3, 2. That also tells us that the axis of symmetry happens at x equals 3. I also notice that the leading coefficient here is a 1 and it's positive. So that means that this parabola is going to open up and it has about the same shape as a regular x squared type parabola. So this opens up and it's not stretched or compressed. Now, this isn't quite enough information to get an accurate sketch, but it's pretty darn close. So the first thing I'm going to do is sketch my vertex, which comes over at 3 and then up 2. There's my vertex. I also know that there's an axis of symmetry that goes right through that vertex. My parabola is going to be opening up, and it's going to be the same on either side of that axis of symmetry. The next thing that I'd like to do is make a little table of values and plot at least one or two other points. So I'm going to come over here, x and y. I already know one point that I can put onto my table. I know that when x is 3, y is 2. Let's go ahead and find out what happens if x is 2. So just one step away from the vertex. I'm going to plug 2 into my equation here. So I have y equals 2 minus 3 squared plus 2, which is negative 1 squared plus 2, which is 1 plus 2, which finally is 3. So when I plug a 2 in for x, I get a 3 out for y. So I can put that point on my graph as well now. Over to 2, and then up to 3. Now remember, this axis of symmetry cuts my graph in half, so I'm really confident that there must be another point over here at 4, 3, since my graph needs to be symmetric around that axis of symmetry. So now I really do have enough information to sketch this quadratic. Must look something like that. There's its vertex, its axis of symmetry, it opens up, and it's not any more stretched or compressed than a regular x squared graph would have been. Now we need to learn how to get a quadratic function into its vertex form from standard form. There are two ways to do this. One is to complete the square, and the other is to use a vertex formula. I'm going to show you both, and along the way I'll give you a couple examples to try. Okay, so here I have f of x equals x squared plus 6x minus 5. We're going to get this into vertex form by completing the square. The first thing to do is go ahead and rewrite this as y equals rather than f of x. So y equals x squared plus 6x minus 5. Now we're going to move the constant over to the other side so that it's with the y. So that means I'm adding 5 to both sides. This is an awful lot like the next step of completing the square to solve an equation. So I have y plus 5 equals x squared plus 6x. Now I'm going to find the magic number and add it to both sides. Remember, the magic number is the coefficient of x, which in this case is 6, divided by 2, and then squared. So that becomes 3 squared, which is 9. So I'm going to add 9 to both sides of my equation here. I'm also going to go ahead and simplify this a little bit. 5 plus 9 is 14, so I have y plus 14 equals x squared plus 6x plus 9. Now that I have y plus 14 equals x squared plus 6x plus 9, I'm going to factor the right-hand side. Now this better factor as a perfect square. That was the point of finding the magic number and adding it to both sides. And sure enough, x squared plus 6x plus 9 factors as x plus 3 multiplied by itself, x plus 3. So this is the same as y plus 14 equals x plus 3 squared. Now I'm going to finish this by getting the y back by itself, subtracting 14 from both sides. And that gives me y equals x plus 3 squared minus 14, which is now in vertex form. I think it's really important to point out that if I multiplied all of this out and combined like terms, I would get back to the quadratic that I started with. This is exactly the same as the y equals x squared plus 6x minus 5. All we've done is change its shape a little bit so that it's easier to graph. And now that it's in vertex form, we can go ahead and do that. The vertex is -3, -14. Remember, it's always the opposite sign of the h thing there. And the axis of symmetry is at x equals -3. Now I'm going to go ahead and sketch this. I decided that I needed to have each square be worth 2 units on my graph in order to get a good sketch. So I went down 14 and then over 3, put my vertex there. I'm going to sketch the axis of symmetry through it just to help me visualize this. And then I went ahead and plugged in one other point, 0 for x, and I got -5 for y. So that's 1, 2, 3, 4, 5. So there's one of my points. Notice that this needs to be symmetric, so I know that I will have another point right over here. And I can draw my parabola now. Okay, now it's your turn. I'd like you to go ahead and try finding the vertex form of this quadratic function by completing the square, and then just state what the vertex is and what the axis of symmetry is. So go ahead and pause the video and give that a try, and we'll do it together when we come back. Okay, are you ready to take a look at this problem together? I started out with f of x equals x squared plus 8x minus 4, and I'm trying to write this in vertex form. So I started by getting the constant onto the other side, away from the x squared and the x. Now I have y plus 4 equals x squared plus 8x. Then I find the magic number and add it to both sides. The magic number is the coefficient of x divided by 2 and then squared, which gave me 16. So I add 16 to both sides. Now I have y plus 20 on one side. And I'm going to go ahead and factor this right-hand side, which gives me x plus 4 multiplied by itself, or x plus 4 squared. The last step is to get y by itself, so I subtract that 20 back over, and I have y equals x plus 4 squared minus 20. Now that my equation is in vertex form, it's easy to read off that the vertex is -4, -20, and the axis of symmetry is x equals -4. This ends the first part of the section 8.6 video. In the next section, we're going to actually derive the formula for the vertex of a quadratic function.